Welcome to Unit 0, Lesson 1 of AP Chem, Significant Figures, also known as sig figs. Well, why are we doing a Unit 0? That's because significant figures are actually needed to be successful in the course and on the exam because they're actually worth points. And College Board only accepts numerical answers that are plus or minus one significant figure for those numbers. So, first let's start off with what is a sig fig. So, a sig fig has many steps to it. So, the first step, or the first rule, I should say, is that any non-zero number is a significant figure. So if we have the number 1, 2, 3, that means that there are 3 sig figs in the number because every number is not 0. The next rule we get to is that leading zeros are never significant. So in the number 0, 0, 1, there's only one sig fig because the two zeros are leading. If we have 0.01, there's still only one sig fig because these two zeros are still leading. Now we get to our next rule. Any zero in between two numbers is significant. So we have the number 101, for example. That means there are 3 significant figures because the 0 is in between two non-zero numbers. If we have 1.01, there's still 3 significant figures because the same thing applies. Now we get to our fourth rule, that the trailing zeros are only significant if there's a decimal point actually there. So if we have the number 100, no decimal point there, that means there's only one significant figure, it's the 1. However, if we have 100 point right at the end of it, nothing after that, that means there's 3 significant figures. So, another example we could do is 1.00. There's still 3 significant figures because there is a decimal point right there. Now, let's move on to adding and subtracting with sig figs. So, this is a relatively simple thing to do. So, when we have two numbers, right? So, we're adding 100 and we're adding 2.2. So, for adding and subtracting, you always choose the number with the least amount of decimal points. So, out of 102.2, which has the least amount of decimal points, it's 100 because it has 0 decimal points. So, when you add them, you would actually just do 102, and you would just leave off the decimal point because it's not significant. That's how the significant figure rule works. However, if we have, let's say 1.01 plus 2.1, and then we'd see that 2.1 has the least amount of zeros, so we'd only look at, our answer would only have one decimal point, and we'd get 3.1. However, if you need to round it too, that also is a thing to keep in mind. So if we're adding 1.09 plus 2.1, now we're actually going to get 3.2 because we want to round the 9, even though we're getting rid of the second decimal point. Okay, now let's move to a little more complicated thing, and it's multiplying and dividing. So these are actually where you need to know the sig fig rules and how many significant figures each number has. So when you have two numbers, so say we have 200 times 2. So how many sig figs does each have? So this one has 1 because only the 2 is significant, and this one has 1. So that means that the answer must only have one sig fig, and that actually just works perfectly. However, this doesn't always work so nicely. So let's say we have a 202 times 2. Now we know that this one has 3 sig figs and this one only has 1. So for multiplying and dividing, you always want to have your answer have the same amount of sig figs as the least amount of sig figs, the number with the least amount of sig figs. So this one has 1 sig fig, so our answer must only have 1 sig fig. And how we do this is we just multiply it out, and then we'd have to but replace the rest of the term with 0. So when we multiply it out, we get 404. However, since there's no rounding going on, we can just make both of these a 0, so it becomes 400 with sig fig rules. So you just need to know that too. Next thing, scientific notation. So we know that scientific notation means there's a single digit right here, point, how many ever decimal points you need, times 10 to the some other random power. It can be positive or negative. So with significant figures, only the coefficient matters. So only this section matters. So if we have 3 sig figs for scientific notation, we'd have something point something something. If you want 4 sig figs, you have something point something 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 times 10 to the whatever. That this number does not affect it at all, only this matters for sig figs. Next thing, so for rounding and significant figures, you want to keep track of the least amount of significant figures, or for adding and subtracting, like keeping track of the least amount of decimal points. And however, don't do it in each step, because that's how rounding error accumulates. So you just want to say that to the last step, but just keep track of that. And then finally, for constants and exact numbers. So if there's a constant given in a problem, like let's say 12 seconds or 10 eggs or something, though that number does not count to the significant figures. It's usually measures, so like 100 milliliters of water, or 2 milliliters of HCl, something like that. And exact numbers are things like 60 seconds in a minute. So if you want to convert from seconds to minutes, that conversion doesn't actually count for the sig figs, because it's already a known like exact number. And that's it for lesson 0.1. Thank you for watching.